The National Electrical Code, or NIC, does not explicitly require a ground fault circuit interrupter, or GFI, breaker for a 50 amps 220 volts service that feeds an outdoor spa installed at a single-family dwelling. However, it is crucial to understand the nuances of the NEC and local codes, as well as to consider safety recommendations. The NEC is a comprehensive set of standards designed to ensure electrical safety. It is updated regularly to reflect new technologies and best practices. While the NEC provides a baseline for electrical installations, local jurisdictions often adopt and amend these codes to suit their specific needs and conditions. Therefore, it is imperative to consult with local authorities or a qualified electrician to determine the exact requirements for your specific location. The NEC addresses the installation of electrical components for spas and hot tubs in Article 680. This article outlines various safety measures to protect users from electrical shock hazards. Ground fault circuit interrupters are a key component of these safety measures. A GFI is a device that monitors the current flowing in a circuit. If it detects an imbalance between the outgoing and return current, which indicates a leakage of current to ground, it quickly trips the circuit, cutting off the power. This rapid response helps to prevent electrical shock. Even though the NEC may not explicitly mandate a GFI breaker for a 50 amps 220 volts service to an outdoor spa, other sections of Article 680 might still apply. For example, the NEC requires all 120 volts receptacles within a certain distance of a spa or hot tub to be GFI protected. This is to prevent users from plugging in electrical devices near the water, which could create a shock hazard. Furthermore, many jurisdictions have adopted local amendments to the NEC that require GFI protection for all spa and hot tub circuits, regardless of voltage or amperage. These amendments are often based on local conditions and safety concerns. It is also important to consider the manufacturer's recommendations for your specific spa or hot tub model. The manufacturer may require GFI protection as part of their warranty or to ensure safe operation. In addition to GFI protection, the NEC also addresses other safety requirements for spas and hot tubs, such as bonding and grounding. Bonding involves connecting all metal parts of the spa or hot tub and its associated equipment to create an electrically conductive path. This path helps to equalize the voltage potential between different metal parts, reducing the risk of electrical shock. Grounding involves connecting the bonding system to the earth, providing a path for fault current to flow back to the source. This path helps to trip the circuit breaker in the event of a fault, further reducing the risk of electrical shock. When installing an outdoor spa, it is essential to follow all applicable codes and regulations. This includes obtaining the necessary permits and inspections. A qualified electrician can help you navigate the complex requirements of the NEC and local codes, ensuring that your spa is installed safely and correctly. Here are some additional points to consider. Firstly, the location of the spa can affect the GFI requirements. For example, if the spa is located indoors, the GFI requirements may be different than if it is located outdoors. Secondly, the type of wiring used to connect the spa can also affect the GFI requirements. For example, if the wiring is buried underground, it may be subject to different GFI requirements than if it is run above ground. Thirdly, the presence of other electrical equipment near the spa can also affect the GFI requirements. For example, if there is a nearby electrical panel, it may be subject to different GFI requirements than if there is no electrical panel nearby. It is also important to note that GFI breakers are not foolproof. They can sometimes trip due to nuisance tripping, which is when the breaker trips even though there is no actual fault. Nuisance tripping can be caused by a variety of factors, such as electrical noise or voltage fluctuations. If you experience frequent nuisance tripping, you should consult with a qualified electrician to troubleshoot the problem. In summary, while the NEC does not explicitly require a GFI breaker for a 50 amps 220 volt service to an outdoor spa in a single-family dwelling, it is essential to consult with local authorities and a qualified electrician to determine the exact requirements for your specific location. Always prioritize safety when installing and operating a spa or hot tub. Ground fault circuit interrupters are crucial safety devices that protect against electrical shock hazards. The purpose of ground fault circuit interrupters is primarily to protect people. The way they achieve that goal is by detecting very small imbalances in current flow. Normal current flows in a circuit from a power source through a load and back to the source. A ground fault occurs when some of that current deviates from its intended path and flows to ground, either through a person or a conductive object. GFI devices are designed to detect these deviations. These devices constantly monitor the current balance between the hot and neutral conductors in a circuit. Under normal conditions, the current flowing through the hot conductor should be exactly equal to the current returning through the neutral conductor. When a ground fault occurs, a small portion of the current leaks to ground, creating an imbalance. The GFI device detects this imbalance. GFI devices are extremely sensitive. They are typically designed to trip when the imbalance reaches a level of 5 mA or less. This level is far below what is needed to cause serious injury or death. When the GFI device detects a ground fault, it trips the circuit very quickly, typically within 20 to 30 milliseconds. This rapid response time is crucial in preventing electrical shock. There are two main types of GFI devices: firstly, GFI circuit breakers, and secondly, GFI receptacles. GFI circuit breakers are installed in the electrical panel and provide protection for the entire circuit. GFI receptacles are installed in place of standard electrical outlets and provide protection only for devices plugged into that receptacle. When selecting a GFI device, it is important to choose one that is appropriate for the application. For example, GFI circuit breakers are typically used for circuits that serve multiple outlets or appliances. GFI receptacles are typically used for individual outlets in areas where there is a high risk of electrical shock, such as bathrooms and kitchens. It is also important to test GFI devices regularly to ensure that they are working properly. GFI receptacles typically have a test button that can be used to simulate a ground fault. When the test button is pressed, the GFI device should trip, cutting off power to the receptacle. If the GFI device does not trip when the test button is pressed, it should be replaced immediately. GFI circuit breakers also have a test button, but testing them can be more complicated. It is best to consult with a qualified electrician to test GFI circuit breakers. Ground fault circuit interrupters are an essential safety device that can help to prevent electrical shock. By understanding how GFI devices work and how to use them properly, you can help to protect yourself and your family from electrical hazards. Also, consider the American National Standards Institute, or ANSI, standards when evaluating electrical safety in spas and hot tubs. These standards provide additional requirements and guidelines for the design, construction, and installation of spas and hot tubs to enhance safety. Firstly, ANSI standards often specify requirements for materials used in spa and hot tub construction to ensure they are resistant to corrosion and degradation from exposure to water and chemicals. Secondly, these standards may address the design and placement of suction fittings to prevent entrapment hazards. Thirdly, ANSI standards often include guidelines for water quality and sanitation to minimize the risk of infections and diseases. The International Code Council, or IC, also publishes model building codes that may be adopted by local jurisdictions. These codes often incorporate requirements for electrical safety in spas and hot tubs. Firstly, the ICC codes may reference the NEC and other relevant standards for electrical installations. Secondly, these codes may include specific requirements for bonding and grounding of spas and hot tubs. Thirdly, the ICC codes may address the installation of GFCI protection for spa and hot tub circuits. It is important to consult with local building officials to determine which codes are in effect in your area. Regarding permits and inspections, before installing a spa or hot tub, it is typically necessary to obtain a building permit from the local government. The permit process ensures that the installation complies with all applicable codes and regulations. During the permit process, the local building department will review the plans for the spa or hot tub installation to ensure that they meet all requirements. Once the installation is complete, a building inspector will typically inspect the work to verify that it was performed in accordance with the approved plans and all applicable codes.